Hi guys, my name is Taylor Guevara and I was given problem 4 on the forces and objects homework, so we'll go ahead and jump right into that. So, I wrote down the question. It says, problem number 4, a competitor in a winter sporting event pulls a 47-kilogram cube of ice in the positive horizontal direction with a cord over his shoulders over a frozen lake, as shown in the figure. Assume the coefficients of static and kinetic friction are mu sub s equals 0.1 and mu sub k equals 0.03. So to start off, I redrew the diagram that was in the homework. So that's the cube of ice, that is the person pulling the ice, and then that is our angle theta that he's pulling the rope at. So this just tells you what our theta, our mu's, and our mass are equal to. So first we're going to draw a free body diagram of what is happening to the cube of ice. So we have the force of gravity pulling down, the normal force pushing up, and then we have the force of friction, which is what's going to drag it backwards when the person tries to pull the ice along the ground. So, problem A is calculate the minimum force F he must exert to get the cube sliding in newtons. So we need to figure out the force to move it in x direction. So F of x is equal to the force of friction. Because you're pulling back, you need the equal amount to get it started to pull forwards. So down here, our force of friction is equal to mu sub s times Fn, which is the force of static friction times normal force. So if we go down here, our normal force is going to be equal to the force of gravity minus the force of Fy, which is going to be our y component up here. Since he's pulling the rope up, that's why we have to plug in that minus Fy, because there's going to be less friction when you're pulling up as opposed to when you're pulling across. And so that is also going to be equal to the force of gravity minus F sine theta. Because if you look, this right here is theta, 25, and we need to find Fy, so you're going to use sine to find the opposite, which will be Fy. And then down here, Fx across is going to be the same as F times the cosine of theta. So F is our hypotenuse, and since we're finding the adjacent, we're going to use the cosine. So after we figured out all of these, we can plug them in to use our equation. We're going to sub Fx for F cosine theta. And then we're going to sub the force of friction for mu sub s times force of gravity minus F sine theta. So we're going to just kind of simplify the problem. So you'll just multiply the static friction times both of those, and then we will subtract the coefficient of static friction times F times the sine of theta to get that over on that side, and then we can take out the F and put those in parentheses, and then at the very end you'll get the force is equal to static friction times mass times gravity all over the cosine of theta plus mu times sine of theta. So right here is where I plugged all those numbers in, and then you should get 48.54. So for part B, what is its acceleration in meters per second squared once it starts to move if that force is maintained? So we're going to do the force minus force of friction equals mass times acceleration. In this problem, since we will be using the coefficient of kinetic friction since it's already moving. So acceleration is equal to the force minus force of friction over the mass. Which if we go back to our previous problem, we know that Fx equals F times cosine of theta. And then our friction, we are going to use the coefficient of kinetic friction since it's already moving. And we'll have to multiply that by mass times gravity minus y, which is that F sine theta all over mass. and then what you should get is 0.6561. So hopefully that helped you guys understand this problem a little bit better. I know maybe down here kind of subbing in the different things can be a little bit tricky, or remembering if you should use sine or cosine. And I just always think of the SOHCAHTOA that we learned kind of in high school, and that kind of makes like an easy mnemonic for you to remember things. And then really this free body diagram is pretty much key for knowing everything, and just remembering to draw this extra little triangle to help you figure out the y and x spots. So hopefully that helped you guys out. Thanks.